Woohoo! Welcome back. Tonight we're going to be working with complex numbers, which is the second step in working with imaginary numbers. Now, an imaginary number specifically refers to the I, which if you were watching the previous video, you know has to do with taking the square root or radical of a negative number. A complex number, on the other hand, is slightly more complex in that the word complex means that it has more than one part, and it's a very formal way of writing numbers so that we're writing a real part and an imaginary part. And so I'm going to show you through a bunch of different examples what that means. So if we just have the letter I, the imaginary constant, that means you have 0 for your real part and 1 I. In the second example, my real part is -3. And again, I have I here, so I'm going to write 1 I. Now, I'm being very formal. Sometimes when folks are writing complex numbers, they don't write in the 1. So you could actually write it as 0 plus I, or in this case, -3 plus I. I've also seen that. So you just need to know how formal are we being, how specific and particular do you want to be. In this case, A is 0 and B is 1. Here, A is -3 and B is also 1. So we've got the A plus BI. That's pretty universal, at least in this country, every time I've ever worked with them. The interesting thing about complex numbers is that real numbers are part of the set of complex numbers. So if we look at the set of complex numbers, there is a piece which is the set of real numbers, and then everything else is the imaginary numbers. And then the complex numbers, so the A plus BI type numbers. But the real numbers sit inside the complex numbers. So you can take a number like 5, which is actually not even just real. That's an integer, that's a rational number, that's a whole number. It's a natural number. But we can write it as a complex number just by saying it's 5 plus 0 I. So there's no imaginary part. And so that's how we can take this set of real numbers and expand it into the concept of complex numbers. Now, how often are we going to do this? Well, it really depends on what your setting is. In this particular class, we're not going to use it a lot. We're going to use a little bit. In some classes, you use it a great deal. In some classes, you wouldn't use it at all. So it really depends on the setting. Okay, so let's do a bunch of examples. Woohoo! Yay! Okay, so right off the bat, my instructions are to simplify. Now, this is unfortunate, and I did it on purpose, because if it just says simplify, then it's not clear whether you have to write it in A plus BI form. So what we'll do for all of these problems is we'll go ahead and work them out, and then we will also write them in A plus BI form, so we get the practice. Okay, so right off the bat, recall that what we're doing is if we've got a radical, a square root, we're looking at it as the number times a -1 and basically splitting up the two parts. Radical 4 is 2, like it always has been, and radical -1, the negative part of that radicand, is going to be I. And then if we want to extend it to the A plus BI form, the formal way of writing it, it's like the difference between having a nickname and being called by your whole name, your given name, first, last, middle, if you have others. So 2I is the nickname, or 0 plus 2I could be how we write it in A plus BI form. So it'll look like that. Okay. Now, every now and again, you're going to see something, and in case this is a little small, let me write it. It's the cube root of -8. You're going to see something like this and then jump right into I. And the answer is, this is actually just -2. And that is because this isn't a square root, this is a cube root. And when you multiply -2 times itself 3 times, you get -8. So when you're taking cube roots of a negative, there's no problem. We don't have to invent whole new number systems for this. You just get straight up -2. So again, the answer here would be -2 or, and recall if we're going to write it as a complex number, -2 plus there's no imaginary part of it right there. So there's our answer. Here's our answer here. Now, I believe in your homework, all the problems will be very specific about whether you need to write it as the nickname or as the more formal a+bi. If you're ever unsure, just go ahead and ask me and we'll figure it out. Okay, radical 100, otherwise known as the square root of 100, is 10. And again, this is a real number, so it's 10 plus 0i. Woohoo. I'm going to piggyback off that one. Okay, next one. I've got radical -100, or the square root of -100. In exactly the same way we did it up here, that minus sign inside the square root, that's where we're going to get our I. And the square root of 100 is 10, so this is going to be 10i, or 0 plus 10i. And it's interesting because, just the one difference, that minus in there, switches it from a purely real number to a purely imaginary number. There's 0 real, so the real part is 0, the imaginary part is 10i or 10. Here, the real part is 10, the imaginary part is 0 or 0i. Okay, so then, since these are numbers, we should be able to add, subtract, multiply, divide, etc. And the answer is we do. And in fact, it's very straightforward. You use like terms. What does that mean? Well, I decided to go ahead and work with a subtraction problem just to make it exciting. Woohoo, subtraction. And so the first thing to know is that imaginary numbers still follow all the basic rules, including the distributive property. So my first set of parentheses would just drop off and I would have 4 plus 3i. And then this minus would either, and it depends on your perspective, if you see it as the opposite, then you have the opposite of these. If you see it as a -1, then you're going to multiply through. And if you see it as a subtraction, you just subtract both of those. Any way you look at it, that minus is going to be a -6. And then a minus is a positive I. And I know that sometimes I's can feel uncomfortable because there's that minus inside the radical. But when you've got it in I form, work with them almost exactly like they are variables. Like instead of an I, if you saw an X, this would work exactly the same way. Then what we want to do is you're going to realize that we've got two different types of number here. We've got the real numbers, and then we've also got the imaginary numbers. And so the real parts and the imaginary parts don't interact really very much at all. They just kind of hang out next to each other. So I'm going to combine the real parts and then combine the imaginary parts. So for the real parts, I've got 4 minus 6. And for the imaginary parts, I've got plus 3i plus I. So altogether, my real part is -2. And my imaginary part, again, think of it as being like a variable, like x. 3i plus 1i is 4i. And this one is conveniently already in a plus bi form, so we're done. Woohoo! Okay, shall we do some more? Yes, let's do some more. Excellent. So for our next set of calculations, what I'd like to do is look at what happens when you start multiplying. Multiplying gets really interesting, and especially down here with numbers 8 and 9, some really wacky things happen. So the rule about multiplying with imaginary numbers is that you should always convert to imaginary numbers. What does that mean? I mean, don't multiply these like this. Go ahead and convert them. So radical -4, or the square root of -4, that's 2i. Square root of 4 is 2, and then the minus makes the I. And then radical 25 is 5. In this form, you can go ahead and multiply. 2i times 5. Again, imagine that's a variable. Imagine it's just an x. 2x times 5, that would be 10x. This is 10i. And then again, it might be 10 plus, or 0 plus 10i, depending on the setting. So again, whether you're allowed to give like the short form or the formal form. The formal form. Okay, number 7. Ooh, dun dun dun. So you might guess with the square root in the middle, the two minuses, like minus, I normally would do this and go plus, not like that at all. This minus and this minus are stuck. They can't get to each other. They don't actually, can't talk to each other. So I'm going to rewrite, like I said before, don't try to do the math with the square roots showing or the radical showing. Switch to i's. So I've got a minus out in front, and then this part right here, radical -4 is 2i. So this minus that's out in front stays out in front. The radical part becomes the 2i, and so I've got the opposite of 2i, or 0 minus 2i, again, depending on the setting. The two minuses can't talk to each other. Now, number 8. Number 8 is really hard because it is very, very tempting to multiply these two. Bring them together and multiply. And imaginary numbers don't work that way. And the best I can tell you is that if this were regular land, real number land, both of these would be undefined and this multiplication would be impossible. But now that we're dealing with imaginary numbers and complex numbers, we can do it, but we have to be very careful. And I'm going to say something that is not mathematical. It's more human. In fact, it may be nonsense, but it's the way I've thought about it for most of my life. It's how I remember not to make this mistake. This minus is the square root of a minus. It's not a full minus. It's something else. And I have to be honest, imaginary numbers aren't really something we can like hold in our hands in the same kind of way. I can't show you, like I could show you a picture of 3 dogs. I can't show you a picture of dogs. I don't even know what that would mean, if it even represents anything. So we've got a different kind of number system now. But this minus inside there and this minus inside there interact in a really interesting way. So again, this is what I recommend. Do not do the multiplication like we did here. Don't try to do the multiplication up here. Convert to the i's. So let's go down here. Square root or radical -4, that's 2i. Square root or -25 or radical -25 is 5i. Now, why am I multiplying? Remember, when two things are next to each other, we have implicit multiplication. That still is good. But let's take a look at what happens. I've got a 2 and a 5 and an I and an I, right? So that is 10i squared. Now here's the kicker. I squared, anytime you see an I squared, that's a -1. That's a definition. This is absolutely always true. When you're dealing with imaginary numbers, I squared equals -1, always. So whenever you see an I squared, you switch it to a -1, and I get -10, which is really interesting. So basically, anytime we take two imaginary numbers, two purely imaginary numbers, and multiply them together, we get a real number. And again, you might want to write this as negative 10 plus 0i, or it might just be negative 10. But it's kind of wild, right? So go slowly, double check and ask lots of questions, because this really is, it's really weird. But I will tell you, a lot of you won't continue on in math, but if you were to continue on in math, you do a lot of calculus, and you redo calculus in graduate school, and then you redo calculus with imaginary numbers, and that blew my mind. That was just about my favorite thing ever. So there is some really cool stuff that happens. Right now, all I can do is vaguely say it's cool. I can't really explain it all, but you're always welcome to come in and ask. But let's do one more problem. So this is a full a plus bi times another full a plus bi. So a formally written full complex number times another complex number. Basically, these are binomials. So weirdly enough, we're going to use FOIL. It's the same pattern. The numbers are going to be a little bit wonky, so we just got to be careful. But first, same rule, 2 times 2. Outer, okay, that's going to be these guys. That's going to be 2 times a negative 3i. Inner, 3i times 2. And last, 3i times a negative 3i. So the first thing I do, I don't try to do anything with the i's. I don't try to simplify anything. I'm just going to look at what I get when I multiply. So that's the first step. Don't jump ahead, because it can get really weird. Okay, 2 times 2 is 4. Here, if I've got a real number here times a real number times imaginary number like that, I can multiply the real number. So 2 times negative 3 is negative 6, and then the I just sits there like it's a variable, like you had x. It works very similarly. Here I've got 3i times 2. I'm going to multiply the 3 and the 2. I get 6i. And then here, last, I've got negative 3 times negative 3. That gives me a negative 9. And then I've got 2 i's, right? Now, in this particular one, if you notice the pattern, hopefully you notice the pattern, this is a 2 plus 3i, and this is a 2 minus 3i. So what happens in the middle? In the middle, everything cancels, which is pretty cool. So then we've got a 4 on the left and a minus 9i squared on the right. And the question is, are we done? And the answer is no. Because, back up here, I squared every time. So i's work just like variables, except every time you see an I squared, you have to replace it with a negative 1. So this is going to be a negative 1. So this is 4 minus 9 times this negative 1. So the I squared is a negative 1 right there. Well, that's interesting, because negative 9 times negative 1 is a positive 9. 4 plus 9 is 13. Or 13 plus 0i. Now, what just happened? Well, what just happened is normally we would get a difference of squares. But because we've got i's, this is 2 squared plus 3 squared. We've got the sum of squares. So imaginary numbers are how we deal with sums of squares. And now we're going to be able to deal with them. And I know, I hear you all saying, oh, joy. That sounds like a lot of fun. It is. It's a different kind of pattern. It's kind of cool. What we're going to do next is we're going to take a little field trip. There's another concept I want to show you called modulo. I just think it's cool, so I'm going to show you that in one video. And then I've got another video that talks about these two. When they look like this, when one's 2 plus 3i and one's 2 minus 3i. So we've got that, usually the difference of squares. These are going to be called complex conjugates. I've got a whole video about complex conjugates coming up. So we'll do a bunch of stuff with that. And in the meantime, go get a snack, maybe take a rest, go pet one of your pets, or, call a friend or play a video game, dance around. Have an amazing time. And then when you're all done with your break, come back, watch some more videos, learn some more math. Know that I'm so, so proud of you. And, woohoo and math on.